Greetings to each and everyone. This is Group 8. Today we are going to tackle about data gathering management, discussing the measures of variance, z-score, and box and whisker plot. Today's topic is entitled The Deep Application of Mathematics in Data Management, with the theme Management of Mathematical Data, a Light of Knowledge. For the objectives, first is to recognize the significance of measure of variation and z-score. Second is to determine when the box and whisker plot is used. And lastly, to use your understanding on how to manage mathematical data in practical settings. How are things going, guys? I hope you're ready for today's online group study topic.
Yes, I'm sure everyone's ready because we all came in time. Shall we start our new topic then?
Alright, then allow me to open the topic and the rest can follow. In the previous group presentation, we have learned about data management. They mentioned that the quantities or qualities measured or observed that are to be collected or analyzed are referred to as data. The measurement of variance, z-score, and the box of whisker plot are still discussed in this lecture. As a continuation of discussion about data management, let's talk about measurement of variation. The degree of variation quantifies the spread of the values. Measurement of spread are also known as a measure of dispersion and measures of variation. There are 6 types of variation measures: range, quartile deviation, interquartile range, mean deviation, variance, and standard deviation. This is also used to identify how varied, distributed, scattered, or far the performance of the group's member are, as well as how close, group, or near they are. It's also described the group's heterogeneity.
Hey, it's exam day, isn't it?
Yes, it is.
We just finished our mathematics exam today, so we are hanging out as a celebration of finishing it.
I don't feel like celebrating it. Sorry.
Why? Don't you want to celebrate passing your exams?
I want to, but I didn't pass the exam. There is like 54 differences of my score from the highest score.
That's a big difference. You mean you were the lowest out of your whole class?
Yes, the highest score was 58 and the lowest score was 5. By subtracting 5 on the least score of class interval and adding 5 on the high score of class interval, the data of having the highest range of 58.5 to 4.5 leads me to find the difference of 54.
That's more than the half of items in the exam, right?
You know what? You should go home and study harder, so the next time you will pass the exam and get a higher score.
Yeah, I should probably do that. I gotta go now. Bye.
In the video presented, they conveyed how range works and how to get it. To further understand it, let's talk about range. How to compute range? The range is the difference between the highest score and the lowest score. It provides the quickest estimate and display the two extreme values of a piece of data. For group data, the range can be computed by subtracting the lowest class interval lower boundary.
Now let's talk about how to compute for interquartile range and quartile deviation. The interquartile range, it is the more reliable measure of variability. It is the difference between 75th percentile of Q3 and the 25th percentile of Q1. Hence, the 50% of the distribution will be falling within the interquartile range. 25% will fall below Q1 and 25% will fall above Q3. And this is the formula for the interquartile range. IR is equal to Q3 minus Q1. Example, solving the interquartile range with a given quartile 1 is 45.25 and quartile 3 is 52.3. Solution, IR is equal to Q3 minus Q1. Interquartile, 52.3 minus 45.25. As we subtracted is, we have the final answer of 7.05. Therefore, the interquartile is 7.5. Now let's discuss the quartile deviation. If you want to get half of the distance of interquartile range, then we simply divide the difference between quartile 3 and quartile 1 by 2. This is the formula. Example, solving for the quartile deviation, given quartile 1 is 45.25 and quartile 3 is 52.3, this is the solution. We will divide 7.05 into 2, which will give us the answer of 3.525, and that is our quartile deviation in this example.
Now, let's discuss how to compute the mean deviation. It is a measure of variation that makes use of all the scores in a distribution. This is more reliable than the range and quartile deviation. This includes ungrouped data and grouped data. First, we have the ungrouped data. To solve the mean deviation for ungrouped data, we use this formula. Meanwhile, for the group data, we use this formula for the group frequency distribution.
Now, let's talk about the variance and standard deviation. Standard deviation, SD, is the most important and useful measure of variation. It is the square root of the variance, SD squared. It is an average to the degree to which each set of scores in the distribution deviates from the mean value. Ungroup data. For ungroup data, this is the formula. Calculate for the mean, get the difference between each score and the mean, then square this difference. Get the sum of the square deviation in step B. Substitute in the formula. Group data. For the group data, organized in a frequency distribution to the standard deviation is computed this way.
Now let's discuss what is z-scores. Z-score is also known as standard score, measures how many standard deviations an observation is above or below the mean. A positive z-score measures the number of standard deviation a score is above the mean. And a negative z-score means the number of standard deviations a score is below the mean. Z-score can be computed using the formula. Example: John got 76 marks in his statistics test. If the marks of the whole class had a mean of 52 and the standard deviation of 8, what was John's standard score? Solution? Now that we have the formula, we are going to substitute its value. Score is 76, mean 52, and the standard deviation is 8. Therefore, the answer is 3.
Now we're going to discuss box and whisker plot. A box and a whisker plot, sometimes called a box plot, is a graph that presents information from a 5-number summary. It is a way of summarizing a set of data measured on an interval scale. We have here a figure of a box and whisker plot. For example 1, draw the box and whisker plot for the following data set, which is 77, 79, 80, 86, 87, 87, 94, and 99. The solution for this is to find the minimum value of Q1, Q2, Q3, and the maximum value. Given the minimum value of 77 and maximum value of 99. For the subset 1, we have 77, 79, 80, 86, and the median is Q1 is equals to 79 plus 80 over 2 is equals to 79.5. For the subset 2, we have 87, 87, 94, 99, and the median is Q3 equals 87 plus 94 over 2 is equals to 90.5. And therefore, we have the minimum value of 77, Q1 is 79.5, Q2 is 86.5, Q3 is 90.5, and maximum value is 99. And this is now the drawn figure.
Now that we have discussed some part of data gathering, hope that everyone will utilize the knowledge that you gained in this group class study. That's all for today. Thank you.